Welcome everyone. We greatly appreciate you being here and joining us for today's webinar. David Boucher will be presenting on gap analysis, a solution to improved process safety management. Just a little housekeeping, this webinar is being recorded, so if you can please ensure your line is on mute. We're going to go ahead and open the floor up for discussion and Q&A at the end. If you're not comfortable with asking questions, you can also type your questions or comments in the chat box, and I will bring them up at the end of the presentation. So with that, I'm going to turn it over to our Vice President of Business Development, Mr. Kenny Darbone. He's going to talk a little bit about our company, and he's also going to introduce David. Take it over, Kenny.
Thank you, Allie. Hello, my name is Kenny Darbone, and as Allie mentioned, I'm the VP of Business Development here at CDI. On behalf of CDI Engineering Solutions, I wanted to again thank you all for joining us today for our webinar on gap analysis, a solution to improve process safety management. CDI is a full-service provider of engineering, procurement, and construction management services, and we have offices across the Gulf Coast and Mid-Atlantic regions. You could go to the next slide there, Allie. From these offices, we service our customers across the U.S. Since COVID-19, CDI has been offering webinars in order to drill down into some of the services that we're going to put on the screen now. Next slide, please. Next slide. We choose these topics by surveying our clients and asking for general areas of interest or concern that affect your current operations. We can't go into all the services here provided, but that would take quite a while. So today, our PSM webinar will be presented by, as Ali mentioned, David Boucher. David has over 40 years of experience in the technical leadership roles in process engineering. David has pioneered PSM best practices, which he has applied to numerous facilities, operations, and products, resulting in simple yet efficient processes. David is an ISO certified auditor and has led many compliance audits, gap analysis, and annual PSM reviews. David, over to you.
Okay. Thank you, Kenny. There's a saying that doing something for 40 years is not the same as doing something 1 year 40 times. When you look at process safety management, many of us in the chemical process industries have done 1 year 40 times. What I mean is that we have not always used our experience to make our lives better. The initial drafting of process safety management was focused on operator error, procedures, and training. By the time it was implemented, it grew to the 14 elements we know today. One of the concerns from the beginning was to maintain the intent of the program, not just the mechanics of the process. After all these years and many interpretations, I'm not sure if we focus on the requirements and lose sight of the intent. The compliance audit is not the best method to track performance and plan resources. We will talk about what a gap analysis is and why it's different than an audit, when to consider using a gap analysis, who benefits and needs it for planning, what are the steps, how to evaluate the data and present the findings, and how to translate the findings into actions, then how to create a deliverable final product. The best way to look at a gap analysis is as a strategic planning tool versus a compliance audit, a required element of PSM. The Wikipedia definition is that a gap analysis involves the comparison of actual performance with the potential or desired performance. It's the gap between what exists and what you want. It's not focused on the records, but on the performance. An audit is the examination or inspection of various records by an auditor, followed by physical checking to make sure that all the departments are following the documented system. The compliance audit every 3 years is often the only common denominator that looks at the entire PSM program. A gap analysis is usually done at the start of a large project before there are records to audit. It is most helpful for new people or people that get a different job in PSM responsibilities. We'll talk about this later. A compliance audit is required every 3 years to check the records of the PSM program. It does not tell the current state, it tells you the history of documents and records. A gap analysis requires a person knowledgeable in the process being measured. In this case, Process Safety Management, PSM, is a tool to compare what we are doing to what we should be doing. Often this analysis is an important report for leadership to understand the status of the PSM program. An audit requires a subject matter expert of the system being audited. These are often operations for procedures, maintenance experts for mechanical integrity. They examine what should have been done. There's usually a conflict when the element owner is the auditor for their own process. A gap analysis is a view of today. It recognizes elements that need resources and lets us look forward to the plan. An audit is always looking backwards. It assumes the system is functioning and has the inertia to continue to function. A gap analysis is one tool to use if our goal is to do much more with the same effort. It predicts a demand to use in workflow analysis for the PSM efforts. The use of statistical tools are important for the consistency in presentation. An audit often uses the same auditor asking the same person to produce the same records. It's repeated every 3 years. The definition of insanity is doing the same thing over and over and expecting different results. An audit focuses on maintaining records. The gap analysis is focused on maintaining the process. The records are a byproduct of the process. Like most activities, manage the process and the performance will follow, and the records will document it. In the words of Steve Covey's third habit, first things first, let's start at the beginning. What are we trying to do? In this case, to determine the gaps in the process safety management program and recommend how to close those gaps. The overriding theme is where are we going and how are we going to get there? When an audit does not have findings or recommendation, it does not mean the PSM process is healthy and functioning. It means that you passed the audit. A project will require a process hazards analysis, a PHA. The PHA does not address how the recommendations are met. It assumes that the PSM program is robust enough to complete the recommendations. This is often a bad assumption. Process hazard analysis are one of the top 4 OSHA citations across the chemical process industry, not because the PHA wasn't done, but because after the hazards were analyzed, the actions or documents were not completed. Once a gap analysis is used, it will be a tool for many other areas. Think of the programs that meet the requirement on paper but are difficult to use in the field. Almost every regulation has requirements that are met. That doesn't always mean the intent was met. When we get the results of a compliance audit, we look at the recommendations to complete the documentation. We assume that fixing the missing records fixes the process. A gap analysis is not intended to pass or fail. The intent is to set direction, intensity, and resources. The direction and intent will change over time as the gaps are closed. Now that we understand the difference between a gap analysis and an audit, and the reasons we should consider a gap analysis, let's get started. Who is the sponsor and what do they need? For example, a corporate level person may be interested in process safety management across all sites and plans joint resources. When different sites make the same product or use common technology, a gap analysis is a great tool to load level the resources and consolidate the efforts. We may want to recommend benchmarking one location's successes to use at the other sites. In a different case, a plant manager may want to help the safety team plan resources and estimate workload and plan the budget. In some sites, the process safety management team may have the latitude and accountability to create a budget, know who the customer is. We'll need an organization chart to plan the interviews. The org chart will help you identify who will you be interviewing. Not all the plants are organized the same. For example, some locations use contract maintenance. Other locations have operations doing some maintenance work. Today, most plants use operations to do some maintenance activities. Think of cleaning filters, unplugging lines, and product changes. If the location is represented or a union location, the interview with operators and technicians may require a plant steward or representative to be present. They may need to pay overtime to do extra work not part of their job description. Be sure the sponsor understands what will be discussed in the closing meetings. We will discuss and disclose information that may be sensitive, not for public disclosure, and shared only with the sponsor. We don't know the history and current events that go on in every workplace. The intent of the element, process safety information, suggests that this report be shared. That's not always true. The plans that we make as a result should be shared. The analysis might never be shared. The recipient of the report must be clear. Do not distribute the product to anyone but the sponsor. Never assume the stakeholders, interviewees, tour guides, or participants are entitled to the copy of the original report. A non-disclosed agreement or confidentiality agreement is also critical. It's important to note that the identity of the people that make comments are not reported as part of the product. They are held separately from the shared data. Most plants have a record management system. This will be saved and stored in a restricted file. Request the numbering system and file path early to control access. The sponsor will distribute as necessary. One way to approach the gap analysis is a simple four-step method. Plan, discover, draft the report, and then complete the deliverables. The documents created as results of these steps are part of the deliverable. The planning process is the most important. We want to be sure that the client and stakeholders understand what is involved and why this is not an audit. The planning stage will include an opening meeting. We must emphasize that sitting in a room, navigating files for documents may satisfy an audit. It will not provide the information needed for this analysis. The correct people must be made available, or the analysis will not produce good data. When we organize the questions, each person is interviewed once. Plan all the questions or conversations for each interview ahead of time. The questions are shared and not a secret. Several people are asked the same questions. Be sure the method and interviews are understood in the planning stage before moving to the discover stage. Many stakeholders think this is an audit. We must consistently and constantly explain the difference. With the COVID-19 protocol in place, the meeting agenda may be an electronic conference. Our industry favors Skype, Teams, and Zoom. Confirm the stakeholders are capable. Also, the individual interviews may need special arrangements, rooms, or partitions. I understand that some companies are installing plexiglass partitions in meeting rooms. Look for records from the user. Operators and technicians have the process safety information and operating procedures. The first-line supervisors have training materials and records. The maintenance technicians should have predictive and preventive maintenance details. When they refer us to a clerk or someone to navigate through an electronic system, it becomes an audit. That's nice, but not why we're here. Expect this to happen. Again, explain that this is not an audit. If that's the only way to get information we need, it's a gap in the program. Record that gap. The last plant I reviewed was very difficult to schedule. The lab and loading worked 5 8-hour days, Monday through Friday. Maintenance worked 4 10s, Monday to Thursday. Operations worked a 12-hour rotating schedule. By scheduling the interviews on Thursday, days and evenings, and Fridays, days and evenings, I could meet with all 4 shifts, maintenance, the lab, and loading. Overtime was required, so the technicians were paid to come out an hour early and stay an hour late. When the raw data is gathered, remember to maintain it as raw data. Use statistical techniques to analyze and present the data. The presentation of the data, conclusions, and recommendations have a powerful impact when prepared with visual summaries, illustrations, charts, and graphs. The people, data, things style works for me. As you move to the fourth step, there is always mission creep. As the interviews in the tour proceeds, while the data is being gathered, it's often time to regroup, review, and redirect. Explain if the data was compromised, not provided, or inconsistent. Specifically, express concern if it turned into an audit and the interviewees showed the inability or reluctance to provide answers. If they just don't know or can't find the data, this is a gap. When the data gathering is complete, it's analyzed and summarized. At this time, we review the raw data. Each of the 14 elements is listed, and a raw data gap is assigned to each. Each element is considered individually. We look at all the documents, conversations, opinions, and feedback to rank it. This part can be subjective. More supporting and corroborating records reduce the subjectivity. We must compile a comment or explanation why each rating is what we assigned. When we have the summary of the analysis, the gaps are ranked on a scale of 1 to 10 for each of the 14 elements. A big gap or opportunity is a big number. This is an example of ranking of the raw data gaps and comments for each of the 14 elements. Like most statistical reviews, a small error here will not change the results. Enough correct data was gathered. Most elements will have inputs from multiple sources. Maintain the raw data gathered earlier for reference. Just because an element has a gap, it does not allow us to start recommending resources. Some elements are much more difficult to complete than others. One way to tell the difficulty is by reviewing the number of internal compliance audit findings and other plants. Richard Boyd did a very good white paper on audit findings. His results suggest that these 6 elements are problematic in this order. I always suspect that compliance audits are skewed and not the best picture, but like we said, with enough good data, some bad data points or outliers won't change the results. In my opinion, a better way to determine the difficulty is to look where others have failed. I assume that OSHA is a credible source of data for the performance of process safety management. They literally wrote the book and are both the inspectors and enforcers. When we look at all OSHA citations for all process safety management facilities in 2016 and 17, the last year reported, we get a more complete picture. Using the OSHA citations, we average them for 2 years and scale them. This number we will call the degree of difficulty for each element based on plant performance across the industry. The far right column represents the estimated PSM degree of difficulty scaled from 1 to 10. Using the recent OSHA citations degree of difficulty in the raw data gap, we'll create a weighted gap. We do this by multiplying the degree of difficulty, column 2, by the raw data, column 3, and get an estimated weighted gap, column 4. The comments from the raw data are edited here to help explain the results. Summarize the results in a table in the order of difficulty. Add the comments and reference for all gaps. This table may be modified to highlight the findings and organize the message. The right column captures the learnings from the interviews, records, and field observations. When we have data to review, it's best to use common statistical tools. In this application, a Pareto chart works well. The 80-20 rule, also known as the Pareto principle, is an aphorism which asserts that 80% of the outcomes or outputs results from 20% of the causes or inputs for any given event. In this review, 4 of the 14, 28%, bad actors account for 82% of the gap identified. I expect most gap analysis to follow the 80-20 rule. These two charts show the same data in different formats. In presenting the data, consider both the audience and the stakeholder. These two charts also show the same data. They show each of the 14 elements and assign the same gap values. The color blocks on the left highlight the bad actors very quickly with color and size. This serves a purpose in communicating the worst performers. The radar chart or spiderweb chart on the right is a good way to review all categories of data on the same scale. It serves our purpose for planning. The further from the center, the higher the value. Using radar charts, we can illustrate the difference between initiating PSM and the difficulty to keep it robust. The left chart shows that a considerable effort was required for all elements. This chart is my estimate after reviewing programs in many plants. The chart on the right is the data from OSHA citations that we created earlier. Findings of this analysis are the degree of difficulty times the raw data equals an estimate of the resources needed. Again, the chart on the left is from the OSHA data. The chart in the middle is the raw data we gathered, and the chart on the right is the product or the resource estimate. You can see that the raw data in the center chart may not provide a correct basis to assign resources when compared to the chart on the right. The deliverable will be an electronic or hard copy of the report. Use traditional report format. Sometimes the envelope is as important as the message. Other parts of the business report can be combined into this list. The title page is usual information about the report, nothing surprising here. Although a potentially short report, the table of contents helps keep the reader focused. I find it necessary. The summary is the overview of the product. If you read this, you should not have to read the rest of the report. An introduction is required. Not everyone knows what a gap analysis is. The intro should be used to describe what a gap analysis is and how it is intended to be used. The discussion is where the charts, graphs, and explanations are. It's where we describe what we did, describe the challenges so the next gap analysis can prepare and avoid the same pitfalls. Most importantly are the recommendations. Remember, only recommendations and not instructions. Be sure not to trap the client into actions that are opinions or one way of doing things. There are many ways to handle these findings. Words have meanings. A record of process safety management findings can be problematic if they appear prescriptive and not suggestive. The conclusion is a brief takeaway as what was determined in the analysis. Findings are notes, comments, and recommendations for planning. They are not cautions or warnings that the process safety system is failing. So, in summary, we talked about what a gap analysis is and why it's different than an audit, when a gap analysis should be considered, who benefits from using this as a planning tool, what the steps are, how to evaluate the data and present the findings, and how to translate the findings into actions. And that concludes my webinar.
Thank you, David. At this point, we can go ahead and open up the floor for some questions. You should be able to unmute your line by hitting *6, and we can open it up for discussion and questions. I did receive a couple of questions in the middle of the presentation here. David, one of them is, can the results of the gap analysis be found and used against a company by OSHA or others in the future?
And that's a great question, and one of the concerns we have, and the answer is yes. This is a discoverable document. All the documents will be discoverable. It's critical that we are careful in our conclusions, that don't prescribe but recommend. So good question, but yes, they are discoverable.
Good to know. Another one, Ken, can you give us an example of an element where the compliance audit is good, but there was usually a gap when the analysis was completed?
Okay, this is another good question, and I think we can talk about the difference between an audit and a gap analysis, and this is one that's close to me because I was involved. In another life, I was writing technical procedures for operating a process. In this case, we were starting up reactors. We wrote a procedure based on starting up the cooling system, and then a procedure based on starting up the charge system, and a separate one for the discharge system. When we went to audit it, we found that the operators would go to the roof of the building and do everything they needed on the roof, which was out of sequence from the procedures but didn't matter. Then they went to the 5th floor and did everything on the 5th floor. So we had a case where a procedure was technically correct, but not what was being done, and not the best way. So in this case, the gap analysis pointed out that while technically correct, it was not a very effective or useful procedure to use. So it got good marks on the audit for procedures, but poor marks on the gap analysis.
Excellent. Okay, do any of our attendees have questions? Maybe questions about how you can apply this knowledge towards your plant environments? No? Okay, David, is there anything else you wanted to cover before we wrap this up?
No, I would like to remind folks that this is being recorded, but I think you'll cover that in the closing.
Thank you. Yes, we greatly appreciate you all spending this time with us. We will be sharing this video on our YouTube channel, and I will individually email each of you a copy of the presentation as well as a link to the YouTube channel so that you can share it with any of your teammates or coworkers that you think may find this information interesting or useful. So thanks again, and we look forward to seeing you next time. Have a wonderful day, everyone.
Okay,
Oh,
bye.
Wait, David, I think we have someone possibly typing. Oh, I thought I saw someone was typing a message. All right, I think that's all. Thank you all.
Okay.
Bye.
Thank you.